All right, guys, now we're getting crazy. Number 15. Before we were finding just our total resistance and then total current. Now from 15 on, we're going to find the voltage, current, resistance value for everything in the circuit here. All right, so, and it doesn't look like I've given you any current values or any voltage values aside from the total voltage of 120 volts. So what we're going to do is we're going to do the same as before. We're going to start to break this down into series combinations and then see if we can find where our parallel junctions are. So let's see, there is a parallel junction there, and we've got parallel junctions all the way across here, which are fairly obvious. And let's see, we've got a series combination right here. So maybe we'll start over on this side of the circuit and move our way back to the source. Okay, so let's see, let's do R7 and R8. We got 15 and 5. Well, we can see that that gives us 20 ohms from there over. Okay, now we've got to find the combination of 3, 4, and 5 because those guys are in parallel. So doing the reciprocal equation, so if we want to find R3, 4, and 5, then we're going to do 1 over 4 plus 1 over 6 plus 1 over 12 Okay, so pause the video here, punch this into your calculator, and again, you should be looking for a value that's less than 4 ohms. Okay, once you put that in there, you'll find that you get 2 ohms as an equivalent. So everything from here over is the same as 1 2 ohm resistor. Okay, I try to set these up so that there's a pattern to this. So let's see, we got 2 ohms, and we can get rid of this guy now because we've already taken care of that. 2 ohms plus the 18, so everything from here down is the same as a 20 ohm resistor. So 3, 4, 5, and 6 is the same as 1 20 ohm resistor. Well, we found that to be in parallel with another 20 ohm resistor. So 20 ohms and 20 ohms, there are 2 paths for that current to flow. So from here over, we're going to have a 10 ohm resistor. Okay, so all this noise over here is the same as a 10 ohm resistor. This 3, 4, and 5 is the equivalent of 2, plus the 18 gives us 20. 15 and the 5 gives us 20 over here, and these two in parallel gives us 10. Now we're moving over to this parallel node, and we can see that we're in parallel with another 10 ohms over here. So we have 10 ohms and 10 ohms. There's 2 paths for current to flow, so everything from here over is the same as a 5 ohm resistor. Nice. That's in series with a 1 ohm resistor, so our total resistance is going to be 6 ohms. Okay, so now we can start to look at the current flow. So let's see, we've got 120 volts for the total for the circuit. We have 6 ohms total, and so our total current is going to be 20 amps. 120 divided by 6 giving us 20 amps. Okay, so let's do another color here for the current. Let's do the current in blue. Okay, so we're going to have 20 amps going out. See if we can change that a little bit. And we're going to have 20 amps coming back. Okay, so at that point we can find the voltage across R1, right? At that point we've got 20 amps going through there, and we've got 1 ohm. So the voltage there is going to be 20 volts, right? So let's do the voltage in green, maybe. Okay, so 20 amps times 1 gives us 20 volts. Now, this is the source at 120. That 120 volts is going to be dropped across this resistor, R1, and this resistor, R2. The rest of this, we can see by this parallel junction right here, the rest of that is in parallel. So that means that the 120 volts is dropped across here and here. We lost 20 volts here. So that means that this voltage right here is going to be 100 volts. Okay, at that point, we can now find the current. We've got 100 volts across R2, and R2 is 10 ohms. So it looks like we're going to have 10 amps flowing in this portion of the circuit. Okay, well, we had 20 amps going out, right? So 10 amps went down here. So over in this part, this must be 10 amps as well. Which makes sense because we had 10 ohms here and 10 ohms here. So we can see that the currents are the same. 20 amps is going to go back to the source. So that means that when 10 amps goes out, then 10 amps comes back. Beauty. Okay, what does that do for us? Nothing much yet. Now, some of you guys can see the ratio method now if I start talking about the voltage. But what I'm going to do is I'm going to show you that voltage was green. The voltage from here to here was 100 volts, right? That goes to here, that goes to here. We had 100 volts right here. So that means that right across here we have 100 volts across this part and 100 volts across R7 and R8. Okay, so let's find the current through here. Here we've got 100 volts across R7, R8. Those guys sum to give us 20 ohms. So we got 100 volts, we got 20 ohms. So the current through that part of the circuit has got to be 5 amps. And then we're going to have 5 amps over here. Here we got 10 amps, so that tells us that this current here is going to be 5 amps as well. The 5 and the 5 summing to give us the 10. Beauty. Okay, so at that point, so again, that 100 volts was across here and here, and we used the total resistance here to find the 5 amps. Nice. Now we can find our individual voltages now. Okay, let's see the voltage in green. Okay, so this guy we got 5 times 15, so we've got 75 volts across this guy. And we know that this guy's got to be 25 because we had 100 in total. And it looks like it is. 5 amps times 5 ohms giving us 25 volts. Nice. What else are we missing? We need a voltage across R6. Okay. Let's see. Oh, and we can also look here. Remember that that was 20 ohms and this was 20 ohms. So these two currents had to be the same because we had the same resistance value. Okay. Let's get rid of those guys. Just so they're going to complicate things a little bit. Okay. So now we need the voltage across R6. Well, let's see. We got 5 amps going across 18 ohms. That's going to give us 90 volts. We have 100 volts from here to here, which means that we have 100 volts from here to here. So 90 volts is lost, leaving 10 volts across each of these guys. Nice, so now all we need is the individual currents, and we know that the individual currents have got a sum to give us 5 amps, because we have 10 coming in, it goes down each of these parallel paths, combines to give us 5 amps there. So here we've got 10 volts, and we've got, 10 volts, and we've got 6 ohms, so that's going to give us, let's see, 10 divided by 6 ohms. That gives us 1.67 amps. Okay. Then on the other one, we've got 10 volts, and we're going to divide by, oh, that's why I'm all screwed up. R3 is 4 ohms. So this is, sorry about that. I just couldn't see where the individual resistance values was. This is 1.67 amps. Okay. Here we've got 10 volts divided by 4, and that's 2.5. So it's easy to make a mistake if you're not looking closely. So that's 2.5 amps. And then here we've got 10 volts divided by 12, and that gives us 0.83. Beauty. The last thing we're going to do is we're going to add up those individual currents, the 2.5, so 2.5, plus the 1.67, plus the 0.83, and that gives us 5. Beautiful. Okay, so it's a matter of just following the currents right through. 20 amps goes out, 10 amps goes over here, 10 amps goes over here. That 10 amps goes down and breaks off into individual currents. 5 amps goes down here. A combined 5 amps comes down here. They recombine to give us 10 amps going back. Adds to the 10 amps that we have here to give us 20 amps going back to the source. All right, guys. Awesome. We were able to, in the time that it took us to do the easier circuits before, we just banged off a harder circuit in 11.5 minutes. Nice job. All right, so hit stop on this guy and then try number 16.